Okay, next we proceed to distinguish what is the difference between weight graphs and unweight graph. Okay, weight graph is basically our weight graph is have a edges. All these graph, both this graph is have a edges, but for weight graph the edges have a value, but for unweight graph is the edges does not have a value. Okay, for example, okay, weight graph, directed graph, and type of graph. For weight graph is directed and indirect, and the edges is associated with the value or weight. So means the edge is have a value. And for example, the edge represents the distance between two cities. The distance, for example, from Pulau Pinang to Kuala Lumpur, how many kilometer? So the distance will be state as our edges. And then for traveling time, for example, from Kuala Lumpur to Melaka, how many hours? So that the number of hours taken from Kuala Lumpur to Melaka known as our weight in graph. Okay, the current in electricity circuit and the cost. And then for unweight graph is consists of directed and indirect graphs. And okay, unweight graph is does not have value, which is not associated with the value or weight. So this means the related information for unweight graph is job hierarchy in organization chart, flow map, frame map. Like organizations in school, we have a principal, so the flow chart or the flow graph is actually we call as unweight graph because the edges does not have a meaning or does not have a value. Okay, for example 7. Example 7 is state that draw a direct graph based on the given informations. Okay, the question already give two set, which is V and E. We know that V is our vertex sets and E is our edges sets. Okay, for V, to answer these questions, you need to state the vertex first. Okay, so the vertex is P, Q, R, S, T, U. After that, we link that, or we write the relation, the line or the edges between P and Q, P and R, R and Q, S and R, S and Q, and S and T. So yes, we know that this question is asked about directed graph. So directed graph means we have a direction. So from PQ, we know that when the question asks PQ, so this means P, the value of P will be our initial vertex. So P is initial vertex and Q is our terminal vertex. So P to Q means the direction is P go to Q, like this, the directions. For PR, P will be our initial and R will be our vertex, so going down in here. And then for RQ in here, Q in here. So R is our initial, Q is our terminal, so going upward. For SR, S will be our initial and R will be our terminal, so going to the left. And then for SQ is S will be our initial and Q will be our terminal, so going up. And then for ST, S will be our initial and then T will be our terminal, so going to the right. U, there's no relation in these edges, so just put dot. Okay, for the questions number for the questions B, there is a loop at vertex Q and RS is a multiple edge such that in P 1, in out of P is 1, okay, in of Q is 3, out of Q is 2, in of R is 0, out of R is 3, in of S is 3, out of S is 1. Okay, in these questions we need to state the vertex first. Okay, we know that vertex is P, Q, R, S. Okay, there's the vertex. The second step is we need to sketch the loop and the multiple edges first. Okay, let's say the multiple of edges, we state the multiple of edges first. So RS, so this is a multiple of edges, and then the loop. Okay, after that we're looking into the degree of each of the vertex or point. Okay, for example, in here P has a one output, so one out and have a one in. Q has a three right, Q has a three out, Q has a two out, so this one out, and then this one is in and out, so that we have a two out. Okay, for the Q we have a three in, one, two, and this one loop in. Okay, for the R is 0, the in is 0, all is out, so out to Q and out to S, out to S. Okay, for the S is, okay, S in is 3, so in 1, 2, and another one is this one 3, PS. And then for the out of S is just 1 going up to Q in here, like that. Okay, next example number 8. Okay, this is example of a weight graph. Okay, we know that the diagrams on the right shows one way paths that Izaro can choose for his running practice. Vertex 1, V1 is the starting positions, and vertex 5, V5 is the ending position before he goes to home. So determine the shortest distance from V1 to V5, the longest distance from V1 to V5, the vertices that must be passed through if the distance of one way run is between 1.4 km and 2.1 km. So we need to state one by one how many possibility that we can use, or we can possibilities way that we can use in order to end at V5. Okay, for example, rows from V1 to V5 are 1, this one, V1, V2, V3, V4 and V5. So we just sum up. V1 is 600, 900, V2 900, V3 500, V4 500. So the total distance will be 2,500 meter. We change it to the kilometer, we'll get 2.5 kilometer. So the second road is from V1 to V2, V4 and V5. So the roads will be 600, this one, plus 800 and plus 500. So you will get 1,900 meter. Change it to the kilometer, you will get 1.9 kilometer. Okay. For the third roads is from the V1, V2 and directly to the V5, 600 and plus 500, so we will get 1,100 meter. Change to the kilometer, 1.1 km. And then for the roads number 4 is from the V1, V3, V4, V5, so 500, we plus with 500, and then we will get 1,500 meter. So we change it, we will get 1.5 kilometer. So as you can see here, we can know. So the shortest distance from V1 to V5 is 1.1 kilometer. That's how we count. And then the longest distance from V1 to V5 will be 2.5 kilometer. And then for the last question is the distance between 1.4 km and 2.1. The distance between 1.1 km and 1 km is this one, the road number 2 and road number 4. So this is how we solve the questions about of weight graph. Okay, that's all for me, and thank you.